Alright guys, so today we're going to talk about matrices. It is a way to organize data. It kind of looks like a table. It's kind of a combination of a table that you may see. You could even see it in science. But it's just another way to organize data, all right? So matrices. Now with matrices, we typically have these brackets around numbers, and they're organized in rows and columns. So let's get into it. All right, you should have this paper in front of you. So what I'm writing on the paper, you should be writing in your notes. Now, big fail from Mrs. Carlock here. Obviously, I spelled it wrong. Forgot the R in there. So matrices does have an R in there. So it's M-A-T-R-I-C-E-S. So apologize for that. All right, so what is a matrix? Okay, so matrix, when we say matrices, we're talking about many. Matrix means just one, all right? So with a matrix is a rectangular array of variables or constants, which are numbers, right? That's what we're talking about, like just numbers, constants, in rows and columns. Okay, so this is an example here. This is matrix C. This is an example of a matrix, right? So we have numbers in this case, or constants, which is what is in that definition, of numbers in rows and columns. Okay, remember columns go up and down, rows are going to go side to side. Okay, so it's just another way to organize information. The reason I really want to make sure that you guys know this stuff is because typically there's 1 or 2 questions on the ACT that has to do with matrices, and they are so simple that they're easy questions to get correct. I just think if you guys take the time to learn them, it's really simple. They're pretty intuitive, meaning they're exactly what you think they would be. You do what you think you would do. So let's go over a couple key terms. So we have dimensions. All right, so when we say the dimension of a matrix, that's very important when we're doing operations with matrices, adding, subtracting, multiplying. It's very important to know the dimensions. So when we list the dimensions, we always list it as rows by columns. All right, rows by columns. So if I take a look at this one here, rows, I have 1, 2, 3 rows. So matrix C is a 3 by 1, 2, 3, 4 columns. So the dimensions of this matrix would be a 3 by 4. All right. Element just means that is any value that you find in the matrix. For example, 9 is an element of this. 0 is an element. 3 is an element. So it's just a term that falls inside of the matrix. So element is a value in the matrix. Now, we can have letters in here. We have variables in our matrix. You'll see some of those here in a minute. But most of the time, it's going to be numbers. All right, remember that rows are going to be left and right, and columns are up and down. So 1, 2, 3, 4 columns, right? So just knowing the difference between the two of those. All right, down here at the bottom, these are just examples of matrices. Okay, so this is a 2 by 1. So we have 2 rows, 1 column. This is a 2 by 3. And then a 3 by 2. So order does matter. It does matter that the rows come first, then columns, because you can see these two matrices are not the same, right? So even though the numbers over here, they both have 2 and 3, the number of rows versus the number of columns is very important to know. Then you get down here to this 5 by 5, which we call a square matrix just simply because you have the same number of rows as columns. It doesn't really matter, but sometimes you may see it listed as a square matrix. There's a 1 by 6 and a 3 by 3. So just more examples of what a matrix looks like. Also realize that we are nicely spaced. Things that are in the same column appear right on top of each other, and the ones that are a row are right next to each other. You do leave space in here. Everything is nice, neat, and organized. So when you make your matrices, you got to make sure that everything is nice, neat, and organized. All right, so let's talk about operations with matrices. Okay, so this is all in your notes. This is all for you just to read. There's not much that you have to write here. So with adding and subtracting, it's pretty intuitive. It's exactly what you think it would be. So here's an example. We're adding this matrix plus this matrix equals this matrix. Now, a couple things. Your matrices must have the exact same dimensions in order for you to be able to add them together. So this is a 2 by 2, a 2 by 2, and look at our answer is also a 2 by 2. So what you are going to be doing is that you just add, subtract the numbers in the position of the first matrix with the numbers in the same position of the other matrix. So for example, if I'm taking this 4, I'm adding it to this 5, and then my answer also appears in the first row, first column. First row, first column plus first row, first column equals first row, first column. So these elements are ending up in the same location in every single matrix. Same thing with subtracting. This is 5 minus 2, which gives me 3. Okay, so everything stays in the same location. So if we put that out in like a definition term, here is your definition of that. This is just giving you an example. So if I have matrix A plus matrix B, so here's matrix A, here's matrix B, my answer matrix would be, this would be A1 plus B1 because they both appear in the first row, first column. Just like here, A2 plus B2, they both appear in the first row, second column. All right, so every element that is in the same position, we add together or subtract. All right, so down here are more examples that you can look over. So here, 4 minus 7, so they're showing you we did 4 minus 7, which gave us negative 3. Here, 12 minus 9, which gives us 3. Right? If I'm taking the last row, last column, so that's 16 minus 12, which equals 4. Okay? Now, when we're doing these problems, you do not have to write out this matrix here. Okay? That matrix there is not necessary. Okay? You can go straight from here to your answer one. Okay? This is just an example. It's just showing you what we're doing. Okay? And then here's an example of a subtraction one. And then here's an example of another addition one. You can see the bigger the matrix, the more numbers you're going to have to add or subtract. It's not difficult by any means. It's simple, just adding, subtracting work. Okay? All right, one more example for you right here. A plus B gives us this. Now, it does tell us in order to add or subtract matrices, the size of the matrices must be the same. So that's very, very important, right? Must be the same. So here's an example where they are not the same. So this is a 3 by 2 and this is a 2 by 2. You can see I don't have elements that are in the same position for every single one. This is first row, first column. Yeah, this is first row, first column. But look, this is third row, first column. I don't have a third row here. So we cannot add these together. So this is undefined. Okay, so if they do not have the same dimensions, it's undefined. Now, you can write out the dimensions and compare them, but a lot of times you can just look at the matrices. You can tell that they're different sizes, so therefore they're not going to be the answer. All right, so here's another. Notice how both the matrices have the size 3 by 3. These two matrices can be added or subtracted because it's a 3 by 3 plus a 3 by 3, and it gives us an answer of a 3 by 3 matrix. All right, here's another example. Notice they are both like a 1 by 2 and a 2 by 1. Yeah, they have the same numbers in their dimension. However, they're set up differently. This one has 1 row, 2 columns. This has 1 column, 2 rows. So it's very different. There is no same location for the elements, so therefore we can't add these together. All right, so that's adding and subtracting. Again, it's very intuitive. It's exactly what you think it would be. You are adding the elements that are in the same location in each matrix, and you put the answer in the same location in the answer matrix, right? This is the very middle number right here. Second row, second column, second row, second column, second row, second column. All right? Okay, so then we're going to get into what's called scalar multiplication. Now, we will not be doing multiplication of matrices by hand. I'll show you how to do that on a calculator later. But we are going to do scalar multiplication. So scalar multiplication means we are taking the entire matrix and multiplying it by a number, okay? So here is definition, right? And then here is an example. So for example, given that our matrix A equals this, 10, 6, 4, 3, let's find 2a. So what that means is I'm multiplying this whole entire matrix by 2. So it looks like this. So 2a equals 2 times this matrix A. So this is very simple. We are simply taking our scalar multiplier right here. So 2 times 10, 2 times 6. You can see it written out down here. 2 times 4, 2 times 3. And then we write our answer matrix. So we can say this. This right here, this part, this is what you should be thinking, right? This is what should be going on in your head. You don't have to write out this part. So here is what we would answer. So 2 times 10 gives me 20. 2 times 6 gives me 12. 2 times 4 gives me 8. And 2 times 3 gives me 6. So there's my answer matrix. Okay, so scalar multiplication just means we are multiplying every element inside the matrix by the number that's outside the matrix. Multiplying every number inside the matrix by the number that's outside the matrix. All right, so this is multiplication. Okay? All right, so let's look at some examples. So flip on over. All right, so again, if we have here for number 1, we see that we're subtracting, so I'm writing the answer matrix. So it's going to look like this. I'm going to draw my brackets, and if you don't have brackets, it's going to be wrong. So we have 2 minus negative 2. So if you want, you can write it off to the side to give you an idea. You also can grab your calculator and do it on your calculator as well, right? So I have 2 minus negative 2. So that gives me 4. So the first number in my answer matrix is going to be 4. And then I have 1 minus 1, which is 0. 6 minus negative 4, which is 10. And then 4 minus 0, which is 4. And then I close off my matrix. And that's it. That's your answer. Okay? So these are pretty simple. They're not difficult in any way, shape, or form. It's just, it can be time consuming, but grab a calculator. Use the calculator to help you out. So here I have 5 plus negative 2, right? So again, most of this stuff you guys should be able to do in your head or again on the calculator. So this is going to give me 3. And then I'm going to do 2 plus 4, that's 6. If you prefer to go straight down, go straight down. So negative 1 plus 6 gives me 5. Negative 3 plus 7 gives me 4. And I didn't make my matrix big enough. You might want to wait and do your brackets at the end. That might be helpful. So then I have 4 plus negative 2, which is 2. And then 6 plus negative 5, which is 1. So there is my answer matrix. And my answer matrix has the exact same dimensions as the two matrices that I'm adding or subtracting. Okay? All right, what I would like for you to do is to complete 3, 4, 5, and 6. All right, so you're doing those 4. And then you also are going to do 7, 8, and 9. Okay, so for 7, 8, and 9, this is our scalar multiplication. Okay, so for example, here we have a negative 3 on the outside of our matrix, so we're going to multiply everything inside the matrix by that negative 3. So I have negative 12, negative 6, negative 9, negative 6. And there's my answer matrix. Okay? All right, so this is what you're going to do. Okay, so here's your to-do list. All right, so you are going to complete numbers 3 through 9. Okay, so you're going to complete numbers 3 through 9, and then you are going to bring to Mrs. Carlock to check. All right, so once you bring it to me to check, then you're good to go. All right. After I check it, then I will give you your second paper, which is then going to just a little bit more practice. But something I want to show you on this, the back side of this. All right, so on the back side of this is a little different because now I'm giving you answers, but we're finding whatever our variable is. Okay, so for example here, I find my x, so my x is here, right? So I need to solve for x. Well, I notice this is in the bottom right corner, this is in the bottom right corner. So somehow I have to get from 3x, and that's got to equal 21. So 3x equals 21, divide both sides, and I get that x equals 7. So in this one, your answer will not be a matrix. It's going to be what is x equal. So notice here, I have I have a matrix minus a matrix, and I give you the answer. So now you need to figure out, find the x, and then solve for that x. So here's x, right? So I'm going to, again, follow, it's in the bottom right-hand corner. It's the last row, last column. So I'm going to go 2x minus 5 equals 1. So I got here and here. So now this is just a simple equation that I have to solve. Add 5 to both sides, divide by 2, and you get x equals 3. Okay? So again, here's what your to-do is. Complete numbers 3 through 9, bring to Mrs. Carlock to check. I will give you, so Mrs. Carlock is going to give second worksheet to complete. And then when you finish that, you're going to bring it back to Miss Carlock and turn it in. And you can turn it into the basket. That way I can check and make sure that you're doing them correctly, but you do have to turn that in. If you do not turn this in, if you do not turn in the second worksheet to me, then I will know that you did not get through everything, so you are not working very hard, and therefore you're not going to get a grade. Okay? So second worksheet, this is a grade. All right, if you have questions, come see me. Thanks, guys.